And so the last thing I want to talk about is circular motions. So um, here you have an object moving with a velocity v, and the velocity vector is perpendicular to the position vector, and it's moving around a circle with the radius r. So the special thing about circular motion is that it always have a fixed um, acceleration, um, which we called it the centripetal acceleration, and its value equals v squared over r, and it always points to the center of the circle. And we can actually prove both this equation and its direction. So using what we have learned in the previous lessons, we can know that the vector v equals vector vx and unit vector x plus the y component. I will just kind of draw them out. Vx and vy, and you can see that the y component is actually pointing downward, which means its sign would be, negative. So here's, I'll put negative sign here, and now I'll replace these. So if I call this theta, so I will have equals this angle also. So that'll be v. I'll put it outside. So the x component is v multiplied with sine theta, right? Minus cosine theta y hat. And well, because we know like acceleration equals dt, right? We can actually have a equal v and d of sine theta, right? For dt and x, and the cosine theta dt and y. Again, we have sine theta equals, here we have, let's look at this triangle. So we have sine theta equals y over r, right? And cosine theta equals x over r, right? So this y is x, and that leads us to a equal v over dy d over dt x hat minus d x over dt y hat, and there's also r here. I put the r outside, and this is of course vy and vx, but so we once again use vy is v cosine theta, and there's also a minus sign too, like we did before, and this is y, and as we already know, cosine theta is x over r. Same for Vx. That leads us to, I'll put the V and the R outside, so V squared over R squared, and we have minus dx, wait no, and we have minus x hat minus y hat, right? And this is basically just the vector x plus the vector y, and also a negative, so right. And we can also put this as r and r hat. So we will have the equation for the centripetal acceleration. And as you can see, there's a minus, which means that it goes the opposite way of the r hat, and of course the r hat would always point toward this direction. This is not the r hat, I'm just pointing out the direction, so yeah.